Hello everyone, in this video we will be solving your exercises from the past week. We will begin by solving the exercises on volume and then move into the revision exercises. So let's begin immediately. In problem number 1 we have a cube that has sides of 5, edges, 5. And we want to find its area, so its surface basically, and its volume. To find its surface we're going to do 6 times the area of one of its faces, so 5 times 5, which means that we need to do 6 times 25, which makes 150. To find the volume, we need to multiply 3 edges, so 5 times 5 times 5, which makes 125. Next up, we have a rectangular prism that has an open top, so its top face is missing. So this exercise has a bit of a mistake, because here it asks for cubic meters when it should be asking for square meters, because it basically wants to know since it's asking how much glass you're going to need. Well, the glass is going to be the outside of the box, basically, whatever you want to call it. Which means that we're not looking for the volume of the thing, but rather its area, since we want the outside of it. But we also need to keep in mind that the top part is missing. So let's actually draw this to figure it out, right? Okay, so I'm going to make the front face be the smallest one, so that would be 0.5 and 0.6. So 0.5 is the width. Oh, okay, so we really can't. So, since 0.5 is the width and 0.6 is the height, we're going to make it like this. That's what it's going to look like. That is what our shape is going to look like. If you remember how we named each side in the video. Again, length is 1 meter, so this is 1. Width is 0.5, and height is 0.6. All right. Now the top part, the top face, is missing. So that means that I need to find the area of each rectangle that makes up this rectangular prism and add them together, but also keep in mind that the top part is missing. So let's first do the two small faces on the sides, right? Their area is going to be 0.5 times 0.6. And this is going to give us 0.3. A multiplication that you can do vertically if you need to, or you can just do it in your mind. But if you want to do it vertically, you can. So the two small faces are 0.3. They're 0.3 square centimeters each. And actually here we should have written the units of measurement here as well. So this is in square centimeters, yeah. And this one is in cubic centimeters. And actually, I made another mistake because this is not given to us in centimeters, it's given to us in meters. So each face is 0.3 square meters here, right? Then we're going to find the faces that are front and back. And their area is going to be 1 times 0.6, which is going to give us 0.6 square meters. And then we're going to find the bottom only, because remember the top is missing. So the bottom only is going to be 1 times 0.5, which is going to give us 0.5 square meters. Now, the entire area is going to be, 2 of these, so 0.3 and 0.3, which makes 0.6, plus 2 of these, so 0.6 and 0.6, which makes 1.2, plus 1 of these, so 0.5. All of this makes 2.3 square meters. If you wanted to, you could have written this as 2 times 0.3 plus 2 times 0.6, and you would have gotten the same result, or you could have done these calculations right away in your mind. Either way works fine. Again, yeah, 2.3, yeah, perfect. All right, now we have a cylinder that has a height of 10 centimeters and a radius. The radius of its faces are 4 centimeters, and we're being asked what its volume is. So, to find the volume, we are going to need to do pi, well, Greek. So let's just write 3.14 times the radius squared. So 4 times 4, that's 4 squared. 4 times 4 times the height, so in this case 10. All right. So I'm going to move this here because I can. And I'm going to multiply 3.14 with 10 first, because I believe that'll make this a little easier. 3.14 times 10 makes 31.4 times. Now I can also do 4.4 at the same time, because the two operations do not come into conflict with one another. You can see that this order is separate from this order, and they have the same priority. So 4 times 4 makes 16. And now I can do 31.4 times 16, which makes how much? 502.4. 502.4. So my answer here is that the volume is 502.4 cubic centimeters. Kybikai katosha in Greek. Now, we have here that the volume of a cube is 64 cubic meters, and we're being asked what the length of each edge is. Well, since it's a cube, that means that whatever its edge is, let's call it x. If I multiply it by itself 3 times, then I'm going to get 64. And you need to figure out, well, what number do I multiply by itself 3 times and get 64? And the answer to that question is 4. So if I multiply 4 with 4 with 4, we get 64. So each side is Each edge is 4 meters. Now, this is a difficult one. This one asks us, we have a faucet that gives out 1 cubic meter of water in 1 minute. So 1 cubic meter of water per minute. It's going to fill a pool that, and it's asking us how many hours is it going to need to fill up a pool that has these dimensions, right? So basically we need to find how many cubic meters is the pool, and then say, well, we're going to need that many minutes, which means this many hours. So let's find how many cubic meters the pool is by doing 50 times 18 times 1.5. This makes, well, 50 times 1.5, and again, because this is multiplication, I can switch these around if I want to, and I do. This multiplication makes 75 times 18. And now 75 times 18 makes 1,350. So we're going to need 1,350 minutes, basically, because that's how many cubic meters the pool is. Right? Well, how many hours, since we're going to need 1,350 minutes, how many hours is that? We need to do the division 1,350 divided by 60. So let's write that over here somewhere. 1,350 divided by 60. Well, the zeros can just go away right now, and I can turn this into 135 divided by 6. But I don't need to. I don't necessarily have to. I say, does 60 fit into 13? No. Does it fit into 135? Yes. How many times? Answer is twice. 2 times 60 makes 120. And my pencil is far too big. 120. I subtract and get 15. Bring down the 0. And 60 fits into 150 twice again. By doing the subtraction, I get 30. Put a decimal point here and a 0 here. And I say 60 into 300 5 times. So we are going to need, our final answer for this question is we are going to need 22.5 hours. And that's our final answer. That's the whole worksheet. If you need to check your answers, stop the video and do. Let's move on. All right. Next up, I told you how to, I reminded you how to turn meters into decimeters and centimeters and so on, then square meters into square centimeters and all that, and also cubic meters into cubic decimeters and cubic centimeters and all that. So this is where that comes in this worksheet, where you need to transform, you need to convert one unit of measurement into the other. Well, here we know that by definition 1 meter has 10 decimeters. 100 centimeters and 1,000 millimeters. 1 square meter has 100 square decimeters. It has 10,000 square centimeters and 1,000,000 square millimeters. And a cubic meter has 1,000 cubic decimeters, 1,000,000 cubic centimeters, and 1,000,000,000 cubic millimeters. Count the zeros. Let's make sure I didn't make any mistakes. 3 and 3 is 6, and another 3 makes 9. Okay. So now we need to figure out, okay, what's going on here, right? We need to convert each of these lengths into the other. So let's go 6 cubic meters into cubic decimeters. It means we need to multiply by 1,000 and we get 6,000. Here we're going to have 6 million. And here we're going to have 6 billion. I just write the number that's in front and then I add 9 zeros. Here we have 8,000, so this is going to be 8. Here it's going to be 8 million. And here it's going to be 8 billion. Here it's already 3 million, so here it's going to be 3,000. And here it's going to be 3. Whereas here it's going to be 3 billion. Here we have 9 billion, so here it's going to be 9 million. Right? Nope, put an extra 0 in there. Wait, or did I? Yeah, see, slipped by me. So here it's going to be 9,000, and here it's going to be 9. Here we have 12.5 billion, so here it's going to be 12.5 million. And here it's going to be 12.5 thousand. And here it's going to be 12.5, which is 12.5. And again, if you wanted to do this a little slower and use the ladder that I showed in the video and multiply and divide, that was perfectly fine as well. Next up, cubic decimeters into cubic meters means step up, divide by 1,000. So this is 6. The same, which means I got to do 4,000 divided by 1,000 makes 4. And the same again, which is going to give me 1. 1,000 divided by 1,000 makes 1. Next we have cubic centimeters into cubic millimeters. So we're multiplying by 1,000 and we get 3 million. All right, yep. Here we have 7,000 millimeters into 7,000 cubic millimeters into cubic centimeters. We're going a step up, so divide this by 1,000 and you get 7. Now we have 4 million cubic millimeters into cubic decimeters, which means we're going 2 steps up, which means we need to divide this by 1,000,000 and we get 4. Next up, this is where I wanted you to keep in mind what I told you about the relationship between liters and kilograms, specifically for water. And that's why I specified for water, because that 1-to-1 ratio, so for every 1 liter, 1 kilogram, that's true for water. But for example, not true for, say, oil or honey. For honey, let's say, because honey is more dense than water, Yeah. 1 liter is more than a kilogram. Wait a minute. Okay, so here, 25 liters is going to be, so 25 kilograms. And here, 100 kilograms is going to be 100 liters. All right, so if you looked at your worksheets, where in the beginning it showed you information about liters, you should have noticed that basically each liter has about 1 cubic decimeter. So that means that 2 cubic decimeters is going to be the same as 2 liters, which is the same as 2 kilograms. And then 25 liters is going to be the same as 25 cubic decimeters, and 100 liters is the same as 100 cubic decimeters. In the next exercise, we want to write these in this form, and then these in this form, basically. So it's vice versa. So here we have 2 cubic meters, 250 cubic decimeters, 300 cubic centimeters. So let's write all of this in cubic meters. We turn all of this into cubic meters. So we have already 2. Then 250 cubic decimeters is going to be 0.25. And then 300 cubic centimeters means I got to divide this by a million. So that's going to make 0.0003. So it needs to be at the 4th digit. 3 needs to be at the 4th digit from the decimal point here. I could also put in the zeros, but it doesn't really matter. So it's this many cubic meters. Next, we have 6 cube. Wait, why did I write 20? There shouldn't be that 0 here. Just 2. We have 6 cubic meters, and then we have 75 cubic decimeters, which means 0.075, and then 80 cubic centimeters, which means it's going to be at the 5th place from the decimal point. So it's this many cubic meters. Next up, we have 380 cubic decimeters. All right, so no cubic meters, so 0.38, and then 850 cubic centimeters, which means this is going to be like this, and then 150. Okay, so that's going to be right here. And it's this many cubic millimeters. Next, we have 8 cubic meters, and then we have no cubic decimeters, and then we have 45 cubic centimeters, so that's going to be 0.45, and then 12 cubic millimeters, so 0.12, and we get this. If you wanted to, you could have turned each of these individually into cubic meters and then added them up all together. Oh, wait, I made a mistake. This should be just meters, not millimeters. All right, next up we have 87 cubic centimeters, which means 0 cubic meters, and 0 decimeters, and 0.87 here, and then 453. And it's this many cubic meters. Next, we have 4 cubic meters, well, nothing in decimeters, and then we have 0.78 cubic meters. All right. Next, we need to do the opposite. We need to turn this into the form where none of the numbers are described as decimal numbers, basically. And so we're going to need to separate them into their individual units of measurement. So we have 6. I'm just going to write C for cubic. So I'm going to write C dot M separated from centimeters, from the cm centimeters. So C dot, we're going to say, is cubic. Normally, if we had like a pencil and paper, and stuff like that, we would write this. The right way to write this would be to write cubic meters, for example, would be this, meter to the third. And for example, cubic centimeter, the correct way to write that would be cm to the third. But because we don't have pencil and paper right now, I'm just going to write C dot for cubic, short for cubic. So 6 cubic meters. And then we have 754 cubic decimeters. Sorry, this should be 54. Why did I write? And then we have 302 cubic centimeters. Okay, great. Here we have 15 cubic meters and 4 cubic decimeters and 25 cubic centimeters and 626 cubic millimeters. There we go. Here, our unit of measurement is given to us in cubic decimeters. So the 76 up front is going to be cubic decimeters, not meters like before. Then the 0.98 means 98 cubic centimeters. And then 120 cubic millimeters. All right. Then we have our next one is also given to us in cubic centimeters, but it's 0 up front. So I'm going to go straight to millimeters. So that would be 760 cubic centimeters, and then 50 cubic decimeters. Next, we have 0.328 cubic centimeters. Since it's in cubic centimeters, that means we have 0 cubic centimeters, and the next one we need to go to is 328 cubic millimeters. Now, this is given to us in cubic meters, 0 cubic meters, 000 cubic decimeters, 1 cubic centimeter. That's this exercise. Pause the video and check if you want to. All right, revision time. Let's get started. We have a problem. One person has 163 euros, the other person has 0.98 more. Our first question is, how much does Alex have? Since he has 0.98 more, that means he has this much, plus this much. So we need to do 163 plus 0.98, which makes 163.98 euros. And the second question is, how much money is that altogether? So we need to do 163 plus 163.98, which makes 323.98 euros. Nope, sorry, 326.98 euros. All right, let's move on to the next one. Okay, so here we want to figure out what's better. So is it better to round up a person's salary to the hundreds, or to round up their yearly salary, which is 12 salaries, in the thousands? So if we rounded this up to the hundreds, it would become 10 hundreds, which is basically 1,000, right? So every 1 month they'd get 1,000 euros, which means that in 12 months they would get 12,000 euros. But currently they're getting 12 times 960. They are getting how much? Let's think about this. Also, let's not make any mistakes. 11,520 euros, right? Now, if this was rounded to the thousands, it would become 12,000 again. So it's basically the same. Either way, it's the same amount. So let's go, next one. Person has 3 barrels of wine. The first one has 465.85 kilograms. The second one has 485.58 kilograms. And the third one has 465.58 kilograms. Okay, which one has the most wine? All right, so in this case, if you remember how to compare decimals, we first look at their integral parts. So this one has 465, 465. This is 485, which means that the second barrel is the most. So out of all of these, he sold 1,250 kilograms. All right, so how much is left? Well, we first need to find out how much he has. So we need to do 465.85 plus 485.58 plus 465.58. We need to add all of that together. So we can do those additions vertically. And what we are going to get is 1,400. Come on, work with me here. 1,417.01. Okay, so that's how much he has. Now we have to do 1,417.01 minus 1,250. And what we'll find from that is 167.01. That's how many kilograms he's got left. All right. We want to write these numbers as fractions. So this number would be 434 over 100. This one would be 26,004 over 1,000. This one would be 1,023. And all these things are things that we've done in the past. This is a review, basically. It's not new things. This would be 13 over 1,000. This would be 104,034 over 1,000. And this would be 437,021 over 1,000. Next, We want to circle the fractions that have a base of 10 and then write them as decimal numbers in the correct order. So let's do that. 1 here, 1 here, 1 here, and 1 here. All right, so this would be 1.2. This would be 9.01. And this would be 0.237. Whereas this one would be a 0.1. All right, the smallest one out of these is this one. So 0.1. And the next smallest one is 0.237. And the next smallest one is 1.2. And lastly, the greatest one is 9.01. All right. So there's the entire worksheet. Pause the video if you need to. And let's move on. All right. Let's see here. We have a person who's having a birthday party. They invited 16 friends. Each person gets a soda, basically, that costs 45 cents. Some food that's 38 cents, and some sweets that 32 cents. Now we need to figure out how much it's going to cost her. And we need to calculate using order of operations. So there are a few ways that we could go about this. The first, and in my opinion, easiest, would be to say, okay, that each person is going to have 0.45 plus 0.38 plus 0.32 euros, and she has 16 people, so that's going to be times 16. So then we just do this addition. 0.35 plus 0.38 plus 0.32. That makes 1.15, right? Right, times 16. And this multiplication gives us 18.4. So in total, it's going to cost 18.4 euros. Now, you could have also multiplied each of these numbers individually with 16. So you could have said, okay, 16 people are going to need 0.45, so 0.45 times 16, plus 16 of 0.38, so plus 16 of 0.32. So you could have written it like this as well. Also, if instead of 0. You just wrote 45, 38, 32, you got your answer in cents. So you should turn that, you probably got 1,840, and you may have wondered how is it possible it costs that much, which, you know, you could have turned that into euros after finding it in cents. That could have worked as well. Okay, so next up, we have Despina, who is collecting 10 cents for a very long time and putting it in the piggy bank. And she broke open the piggy bank and she had 46.7 euros. And it's asking how many 10-cent coins is that? So here we need to do 46.7 divided by 0.1, because remember, it's in euros, and 10 cents in euros is 0.1. And if we do this division, what we're going to find is We can do this vertically as well if we need to, but what we find is 460. So she needs to have 460 coins. Here we have a question about whether or not it is possible to divide a number by 0. And the answer is a big no. The reason for that, and it asks for an example, is let's say we have division 3. I'm going to give you two examples, one that's possible and one that's not. So let's say I have the division 20 divided by 4, right? If you have, that's a very simple division, right? You need to think how many times 4 makes 20? And the answer is 5. Well, in that case, the answer to the division 20 divided by 4 is 5. Okay, now imagine that instead of 20 divided by 4, you say 20 divided by 0, right? Well, then let's ask ourselves how many times 0 makes 20? And see, the problem with that here is that no matter what you put here, no matter what you multiply with 0, your answer will always, no matter what, be 0. And that means that it doesn't matter what number I'm dividing here. I could put anything else, random numbers, right? I could put anything here. It does not matter. It does not change the fact that no matter what I multiply with 0, I am always going to get 0. I'm never going to get anything other than 0. So it doesn't really matter what I'm dividing. If it's a whole number, a decimal number, it doesn't matter. If I try to divide it by 0, I'm not going to find the answer. But there is the interesting case of 0 divided by 0. Now try to think about that. And we'll talk about that when we get back to class. Maybe. So that's the whole worksheet. Pause the video if you need to check. And let's move on. All right, here we have a problem as well. Here we have the population of Greece being 10,815,197. And we're being asked what each of the numbers 5, 8, and 9 represent. You should say 5 is the thousands, 8 is the hundreds of thousands, and 9 is the tens. Here we're being told that in 2001 it was 10,964,020. It's being we're being asked if it went up or down, if it increased or decreased. Then the answer is it decreased. Oh, sorry. You need to keep in mind that it first gives you the population in 2012, right? So that's in the future. Then it gives you the population in 2001, right? So in 2001, it was 2,900,000 something. But in 2012, it was 10,800,000 something, which is less than this. So it decreased by the difference of those two numbers. And the difference of those two numbers is how much? It is 148,823. And that's this worksheet. That's all. Check it and Pause the video if you need to. Let's move on. Here, let's start from the beginning of the worksheet. Okay, we need to write these numbers that are written with words with actual numbers, and here we need to write them with words. So 2,160,027. So 2,160,027. Next we have 15 2/10 is a fraction. So we're going to write it 15 2/10, like so. Should be written like that. And this, if you want to be completely accurate, should be written as 15.2. It's decimal form. Either of these would be acceptable. Now, here we have 78,002,089, which in Greek would be 78 εκατομμύρια 2,080. And now, and the last one is 3.056. So I could write this as 3, then x. And saying 3.56 would actually be wrong because this is the number 3.56, and that's a different number with a different value. We need to write these fractions as decimal numbers, and then the decimal numbers as fractions. So 35/100ths is going to be 0.35. 785 1,000ths is going to be 0.785. 6 1,000ths going to be 0.006. 59.22 is going to be 5,922 over 100. 1.3 is going to be 13 over 10. And 75.157 is going to be 75,157 over 1,000. 1,000. Come on. Here we need to figure out the value of these operations. So we have 64 plus, open parentheses, 20 times 4 minus 2 plus 8 divided by 2, closing parentheses, divided by 2. So if you remember correctly, we say that in order of operations, parentheses have priority over everything. And the inside of the parentheses is treated as a completely different order. So here we need to figure out which of these needs to go first. Is the 20 times 4, 4 minus 2, the 2 plus 8, just 8 divided by 2. So let's get started. 64 plus stays the same. Right? And the parentheses are going to stay like this until we have no more operations left to do inside them. So what should go first? Well, 20 times 4, multiplication and division have priority. And can we do them at the same time? Consider this. The 20 times 4 does not interrupt the 8 divided by 2. Since their circles don't come into contact with each other, I can do both of them at the same time. So 20 times 4 is going to give me 80 minus 2 remains unaltered, plus 8 divided by 2 gives me 4, closing parentheses, divided by 2. Now this is equal to 64 plus remains the same. Open the parentheses. 80 minus 2 plus 4. Well, this subtraction and this addition have the same priority. And what happens when we do that? We do the one that's first from the left. So we're going to do 80 minus 2 first, which is going to give us 78 plus 4 divided by 2. So this is going to be equal to 64 plus 78 plus 4 is going to give me 82, and I will no longer have any operation left inside the parentheses. So I can just drop the parentheses. I can just leave it as 82 divided by 2. Now, out of these, the division has priority. So 64 plus 41, and that's going to give me 105. There we go. It wants us to do these additions and subtractions, and there's actually multiplications too. Okay, now we can do the addition and the subtraction without needing, we don't really need to write them vertically. So here we can just say, okay, this is going to be 282.96. And here the subtraction is going to give us 74.46. Now this multiplication, okay, let's actually do it vertically. 3 points. I'm going to write the number with the more digits on top. So I'm going to put the 25 on the bottom. 5 times 9 makes 45. All right, 4. All right, 5 carried 4. 5 times 4 makes 20 plus 4 makes 24. All right, 4 carried 2. 5 times 2 makes 10 plus 2 that I carried over makes 12. All right, 2 carry 1. 5 times 3 makes 15 plus 1 that I carried over makes 16. 0 beneath the 1s. 2 times 9 makes 18. Right, 8 carry 1. 2 times 4 makes 8 plus 1 makes 9. 2 times 2 makes 4. 2 times 3 makes 6. I add 5 and 2 and 2 and 1 and 8. And we need to have 1, 2, 3 numbers to the right of the decimal point. So my result is 81.225. Okay, next let's do the division as well. 262 divided by 0.4 divided by 32. So let's see what that's going to give us. 32 does not fit into 26, but it does fit into 262. How many times? I'm going to try 8. We'll see. This is going to give us what? All right, and this subtraction is going to give us 16, which is good. Yeah, 16 is less than 32. All right, then I want to pull down the 5, but since I meet the decimal point, the 4, but since I meet the decimal point, I need to put a decimal point in my quotient. Now I can pull down the 4. They say how many times does 32 fit into 164? And the answer is, I'm going to try 4. Actually, I'm going to try 5. 5 times 32 is going to give us 160. Subtract here, and I get 4. I add another 0. 32 fits into 40 once. This subtraction is going to give me 8. Okay, I'm going to continue over here. We were at 8. Come on. And I'm going to put another 0. Fits twice. 80 minus 2 times 32 gives me 64. The subtraction gives me 16. I'm going to add another 0. 32 fits into 165 times perfectly. And we are done. Our result is 8.5125. All right, here we need to do the exponents. So 2 to the 4th. 2 to the 4th means 4 2's multiplied with one another. So 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. 5 squared means 2 5's multiplied with each other, so 5 times 5, which gives us 25. And that's the entire worksheet. Pause the video if you need to. And let's move on. 2 more. Come on. All right. I want to write these as exponents. And the answer here would be 5. Since we have 3 5's, this is 5 to the 3rd. All right. Here we have, come on, 2 to the 3rd times 3 squared. I could have said this 2 cubed, but it's the same. Here we want to write this number with numerals and then with the use of the powers of 10. So here we have 24 billion means 24 billion means 24 and then 1, 2, 3, 1, 2, 3, 1, 2, 3 zeros. That's 9 zeros. That's what billion is, right? But then if you remember, this is basically equal to 24 times a billion, right? So all right, knock out 1, 2, 3, 1, 2, 3. Yeah, I'm missing one. I could put dots in to make sure. And 1 billion is basically, if you remember from when we were doing exponents, 10 to the power of 9, 10 to the 9th. Because when you have 10 to the power of a number, let's say 6, for example, your result is equal to 1 with this many zeros after it. So if it's the 6th power, it's going to be 1, 2, 3, 4, 5, 6 zeros. So that's a million, right? If it's 10 to the 7th, it's going to be 7 zeros. If it's 10 to the 8th, it's going to be 8 zeros. Here, because it has 9 zeros, that's basically like saying 10 to the power of the 9th. So 24 billion is equal to 24 times 10 to the power of 9. Next, we want to round these numbers to the tens and then to the hundredths. To the hundredths. So the tens means I need to look at their tens, 2 and 5. I need to look at the previous numbers from them, so the ones. And if the ones are 5 or more, I round them up. But if they are less than 5, I round them down. Means if I round them up, that means I turn this number plus every number after it into 0. But the tens get a plus 1. If I round down, I just turn that digit and everything after it into 0. So since we want to round to the tens are here, the 2. I need to look at the digit that's next to it, so the 4. The 4 is less than 5, so that means that it and everything after it will become 0. So in this case, the 1 and the 2 will be fine, but everything else becomes 0. And if I want to, I can also just delete all of these, since there's no point in having a decimal part that's 0, 0, 0. Here, I want to round to the tens, which is the 5, so I look at the digit that's next to it. It's a 6. It's more than 5. So I'm going to round up, meaning that I turn everything from this digit and to the right into zeros, but the tens get a plus 1. So they're going to become 6 instead of 5. So we're going to have this. And again, I can just not write this. If the decimal part is 0, I can just not write it altogether. Then we want to round to the hundredths, which is right here. It's the 9 here and the 7 here. So what we're going to do is we're going to look at the digit that is right next to it to the right. In this case, it's a 6, meaning I need to round up. This is going to become a 0. Doesn't have anything to its right. And the digit next to it is going to get a plus 1. 9 plus 1 will make a 10. So I'm going to write 0 and carry 1. And this 2 will become 3. And the zeros I can erase completely. Here, the 56.372. I want to round to the hundredths, meaning that I need to look at this. This is less than 5, so I'm going to round down, means I'm going to turn this into 0. It doesn't have anything to its right, but if it did, I'd turn that into 0 as well. So I can just not write it at all. All right, next up we have a florist. He has 18 white, 24 red, and 30 pink roses. And he wants to make bouquets that are all the same. And we want to figure out how many common bouquets he can make without having any roses left over. And it's asking us how many roses each bouquet is going to have. So, this might seem a little odd, but if you remember, we solved problems like this when we were doing factorization, when we were doing, basically, we were trying to figure out the greatest common factors of numbers. So here, for example, we need to find the greatest common factors of 18, 24, and 30, right? So what does that mean? That means we need to figure out the biggest number that I can divide all three of these numbers with. So the biggest number I can divide 18, 24, and 30 with. In this case, the biggest number I can divide all of them with is 6. 18 divided by 6 is equal to 3. 24 divided by 6 is equal to 4. And this is something that we just know from our timetables. And 30 divided by 6 is equal to 5. So that means that he is going to make 6 bouquets. He is going to make 6 honeywright bouquet. So that's B, come on, B-O-U-Q-U-E-T. Okay. 6 bouquets of 3 white, 4 red, and 5 pink roses. Like our results here, 3, 4, 5. See? 3, 4, 5. 6 bouquets like that. That's our answer. So here we have grandma. She bought 4 3/10 kilograms of oranges and 1 2/5 fewer kilograms of mandarin. So we need to find the difference basically, and then we need to find the sum. We need to do this minus this, and then this plus whatever we find. Okay, so let's do that. Okay, maybe not. All right, let's just write it. 4 3/10 and then minus 1 and 2/5. All right, now you can't subtract them the way they are right now. First of all, you need to have them as like fractions, so they need to have the same denominator, right? But also, it would be easier for you, it would be more sure for you if you turn them both into improper fractions. Just right away, just turn them into improper fractions. So you do that by multiplying the denominator with the whole number and then adding the numerator. So here, for example, you turn this into 10 times 4 makes 40 plus 3 makes 43 tenths. So this, be equal to 43 tenths minus the other fraction would become 5 times 1 makes 5 plus 7 plus 1 plus 2 up here makes 7. So we get 7/5. Now again, they are not like fractions. They do not have the same denominator. So I would normally do the hats trick. So if we do hats, we need to first figure out the least common multiple between 10 and 5. That is 10, which means this hat has a 1 and this hat has a 2, which means these fractions turn into 43 tenths minus 14 tenths. And this subtraction gives us 43 minus 14 makes 29 tenths. All right, so that's how many kilograms of mandarin she bought. So to find the amount of kilograms of fruit, we would have to add this and this. So we're going to do 43 tenths plus 29 tenths. And 43 plus 29 is going to give us how much? 72 tenths. And if you wanted to write it as an mixed fraction, you would say 72 divided by 10 makes 7, with a remainder of 2, and then the denominator stays the same, so tenths. So as a mixed fraction, it would be 7 and 2 tenths, if you wanted to. Next up, we have 9 and 3/4 liters of wine, and then we put that in bottles that each fit 3/4 each. So we want to figure out how much that filled up. Basically, we want to do this divided by this. But first, we need to turn this into an improper fraction. To do that, 9 3/4 is equal to what? Let's see. 4 times 9 is 36 plus 3 is 39 quarters. All right. So now we want to do 39 quarters divided by 3/4. And if you remember how we do this, what we do is basically we just flip the fraction that's second, we just flip it around. Whatever is on one moment. Whatever is on the bottom, we put it on top, and whatever's on top, we put it on the bottom. So 3/4 is going to become 4/3. And also, division symbol becomes multiplication. So 39/4 times 4/3. And this is going to be equal to 39 times 4 over 4 times 3. And this once you do the calculations, it's going to be equal to 13. 39 times 4 is going to give you 156. And 4 times 3 is going to give you 12. 156 divided by 12, because again, we've said this many times in the past, fractions are basically division. 156 divided by 12 makes 13. So that's the whole worksheet. Pause the video if you have to check. And let's go for the last one. All right. We do the order of operations here, so let's get started. 4 inside the parentheses, 4 times 5 plus 6 divided by 3. 4 times 5 and 6 divided by 3 can be done at the same time because they don't intrude on one another. So we get 4 times 5, 20, plus 6 divided by 3, 2. Multiplied by 5 minus 5. Inside the parentheses, we're going to do 20 plus 2, which makes 22. And there will be nothing left to do inside the parentheses. So let's just get rid of them. 22 times 5 minus 5. The multiplication goes first, and I should be writing equal signs. 22 times 5 makes 110, minus 5 makes 105 is the final answer. Next up, 0.7 times 8.2 plus 1.8 makes 10. And there's nothing to do inside the parentheses after that, so we get rid of them, so just 10. Plus 10. The multiplication takes priority, so 0.7 times 10 makes 7 plus 10, and this makes 17. Next up, we have 18 divided by 3 plus 5 plus 2 times 3. 18 divided by 3, so the division and the multiplication have priority, and they don't intrude on one another, so I can do them both at the same time. 18 divided by 3 makes 6 plus 5 plus the 2 times 3 gives me 6. And this is equal to, well, I can do this all at once. This makes 17. Next up, we have 26 minus 7 plus 3 times 4 plus 28 divided by 7. Now the 3 times 4 and the 28 divided by 7 can be done at the same time. So we get 26 minus 7. And actually that can be done too, but let's not get into that. Plus 12 plus 4. 3 times 4 gives me 12, and 28 divided by 7 gives me 4. Now we're going to do the subtraction first, so we're going to get 19 plus 12 plus 4. And altogether, this gives us 35. Great. We have more rounding. So here, we want to round to this digit. The next one to the right is 7. It's more than 5. So I'm going to round up. This one turns to 0. And this one gets a plus 1. 27.47. Here, the one to the right is a 9. It's more than 5. So we round up this, and the 5 becomes 0. And the 6 gets a plus 1. So 189.7. And the rest is zeros, and I could just not write it at all. Here we look to the right. 3 is less than 5, so we round down. So simply it And everything else to the right turn into 0. So we'd have 52. Now that I look at it, I'm not entirely sure. I'm sorry, but I've been looking at the screen for many hours now, and I really can't tell if that's a decimal point. And the same goes for the previous one as well. That's a decimal point or a... Oh no, that's actually not a decimal point. That's a... So this should have been left here. This 0 should have been here. As 27,470. And the same goes for this one. This will become 52,000. But this is a decimal point. So here, well, it was a good call to erase the rest. All right, so this is a decimal point as well, and we want to round to the ones. So we look to the right, there's a 0, which means we've got to round down. Everything becomes a 0 after the 0. So we would get 9.00 or just simply 9. Okay, so here we want to factorize these numbers. So let's see. What is the smallest number I can divide 128 with? Let's divide it by 2. We'll make it 64. And we'll ask, can we divide it by 2 again? And the answer is yes. It becomes 32. And can we divide by 2 again? Yes. It becomes 16. Can we divide by 2 again? Yes. It becomes 8. And this continues a few more times. How many 2's is that? That's 7 2's. So what this means is that 128 is equal to 2 to the power of 7. If you multiply all of these together, you're going to get 128. Next up, we have 625. Can we divide it by 2? No, it's an odd number. Can we divide it by 3? Let's think here. No, because remember the divisibility tests. In order to be divisible by 3, then the sum of its digits needs to be divisible by 3. And 6 and 2 and 5 make 13, which is not divisible by 3. And it's not divisible by 4 because 25 is not divisible by 4, but it is divisible by 5. And it gives me 100 and... No, not 105. Sorry. 1, 2, and then 5. Yeah, 125 is what I'm going to get. And this is also divisible by 5, and it's going to give me 25, which is also divisible by 5, until we get 1. So 625 is equal to 5 to the power of 4, 5 to the 4th. Because look, 4 5s here. 68 is divisible by 2, and it becomes 34. And 34 is divisible by 2, it becomes 17, and 17 is not divisible by anything other than itself. So 68 is equal to 2 squared times 17. 343 is not divisible by 2, it is not divisible by 3, or by 4, or by 5. It's not divisible by 6. It is divisible by 7, however. 7 goes into 34 4 times. And then into the 63 9 times. And you could have done that division off to the side somewhere. And then 49 is divisible by 7. Did I make a mistake here? No. Okay, well. Anyway, I'm going to get a 7 here. And another 7. And finally a 1. So 343 is equal to 7 to the third. And that is it. That is all your homework. That will be all for today. Have a great weekend. See you again on Monday. Bye.